Up first is mechanical energy. At the top of the hill, the coaster has potential energy. As the coaster moves down the hill, it now has kinetic energy, or energy of movement. So mechanical energy is the total of the potential energy plus the kinetic energy. Nuclear energy is energy stored in the nucleus of an atom. When large atoms such as uranium or plutonium are split into two smaller atoms, in a process called fission, energy is released.
There are lots of different scales for measuring temperature. Fahrenheit and Celsius are the most commonly used in everyday life, but Fahrenheit is almost never used in science. The Celsius scale is based on the freezing point and boiling point of water. But even the Celsius scale isn't the best, because absolute zero on the Celsius scale is negative 273.15 degrees. The Kelvin scale is based on absolute zero and starts at 0 Kelvin with no negative numbers. 1 degree Celsius is equivalent to 1 degree Kelvin.
When we are in a stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. When velocity changes, we have acceleration. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity.
The city sky is frankly rather boring. If you look up at the patches of murk between buildings, you might be able to pick out the Big Dipper, or perhaps Orion's Belt. But hold on, look at that murky patch again, and hold out your thumb. How many stars do you think are behind it? 10? 20? Guess again. If you looked at that thumbnail-sized patch of sky with the Hubble Space Telescope, instead of points of light, you'd see smudges. These aren't stars. They're galaxies, just like our Milky Way. Cities of billions of stars, and more than 1,000 of them are hidden behind your thumb. By staring up at the stars at night, you've taken part in the oldest science in human history. The study of the heavens is older than navigation, agriculture, perhaps even language itself. Yet unlike other sciences, astronomy is purely observational. Although they are separated over 2,400 years of history, each of them contributed to answering the eternal question: what is stuff made of? It was around 440 BCE that Democritus first proposed that everything in the world was made up of tiny particles surrounded by empty space. And he even speculated that they vary in size and shape, depending on the substance they compose. He called these particles atomos, Greek for indivisible. Whereas Democritus's atomism had been purely theoretical, Dalton showed that common substances always broke down into the same elements in the same proportions. He concluded that the various compounds were combinations of atoms of different elements, each of a particular size and mass, that could neither be created nor destroyed.